Alright, we're talking about triangle basics today. So, triangle is a plane, closed figure formed by three segments joining three non-collinear points. So, you should have three non-collinear points, so they're not on the same line. And you should have three straight line segments connecting those. So, you have three sides created by those segments, and it should be closed. Alright, so there's an example of a triangle. A triangle is made up of three components: vertices, sides, and angles. The vertices are kind of like the corners. They're the points at each corner there. So the vertices in this particular example would be P, Q, and R. Those are the three vertices in this situation. And again, those are the corners or the points. Then we have the sides. The sides, you got this side right here, line segment PQ. This side over here, line segment QR. And this side over here, line segment PR. So the sides are all segments. And then every triangle has three angles, one at each vertex. So you have angle P, angle Q, and angle R. Those are the three angles. Alright, you can classify triangles by sides and by angles. Let's talk about classifying triangles by sides first. A scalene triangle is a triangle with no congruent sides. So if we got a triangle here, each side is going to have a different length. None of the sides are the same. None of the sides are the same length. An isosceles triangle is a triangle that has two congruent sides, or more technically, they'll say at least two congruent sides. So if two of the sides are congruent, that is an isosceles triangle. An equilateral means a triangle with all three sides congruent. So all three sides are going to have the exact same length. So those are the three possible classifications of a triangle based on its sides. Let's talk about classifying. Let's see, now we'll get to angles here in a little while. Classifying triangles by sides. Let's try that again. Alright, right here, you should notice.
If you're in the building, please come to the front office. Kayla Livingston, if you're in the building, please come to the front office.
Nice to get that announcement on the video. Here you got all three sides congruent, so that is an equilateral triangle. Here, notice none of the sides are the same, so that is scalene. And here you got two sides congruent, one side's different, so this is isosceles. Alright, now that we know how to classify triangles by sides, let's talk about a couple of theorems here. We got the isosceles triangle theorem. It says if two sides of a triangle are congruent, then the angles opposite the sides are congruent. The reason it's called the isosceles triangle theorem is because two sides of the triangle are going to be congruent. So this only occurs in isosceles triangles. Then the angles, actually it can occur in equilateral triangles as well, but to a different degree. We'll talk about that later. So these two sides have been marked congruent. Because of that, the angles opposite those sides are congruent. So angle B is opposite line segment AC. When we say opposite, they're on opposite sides of the triangle. Another way you can think about that is this side goes from A to C. The only vertex that is not a part of this side is the vertex of the angle that is opposite that side. So B is opposite this side, and then this side is opposite angle C. So because these two sides are congruent, we know that these two angles are congruent. Angle B is congruent to angle C. And then we have the converse of the isosceles triangle theorem. Remember, converse just means you switch P and Q. Okay, you switch the hypothesis and conclusion. So we're still dealing with an isosceles triangle, but this time it's that if the angles are congruent, two angles are congruent, then the two sides are going to be congruent. So that's how it becomes an isosceles triangle. So if these two angles of a triangle are congruent, then the sides opposite those angles are congruent. So line segment DE is opposite angle F, and opposite angle E is line segment DF. So if I have two sides congruent, I know those two angles will be congruent. Converse is also true. If two angles are congruent, then I know those opposite sides will be congruent. Okay, so down here, as soon as I notice that these two sides are congruent, I know the angles opposite those sides have to be congruent based on the isosceles triangle theorem. So these two angles are congruent. Well, anytime things are congruent, we set them equal to each other. So there's our equation, and now we just got to find the value of x. We just got to solve the equation. So I don't want x on both sides, so I'm going to subtract 4x to get rid of it on one side. Then I want to get x all by itself, so I'm going to move the 4. And then I'm going to divide off the 5 to get rid of the 5. So x is 3. Okay, on the other one, you should notice that these two angles are congruent. Because those angles are congruent, I know the sides opposite those angles have to be congruent. And once again, if things are congruent, we set them equal to each other. So there's the equation, and now we can solve for x. And you should get x equals 8. Alright, now we've talked about classifying triangles by sides. Let's talk about classifying them based on angles. Alright, an acute triangle is one that has 3 angles that have measure less than 90 degrees. In other words, all 3 angles are acute. Okay, so one possible example of that would be this right here would be an example of that. Acute just means less than 90. 70 is less than 90, 60 is less than 90, and 50 is less than 90. So in that situation, all 3 angles are less than 90 degrees. So this is an acute triangle. Okay, an obtuse triangle is a triangle with one angle that has a measure greater than 90, because an angle that's greater than 90 is obtuse. Now, it had to have 3 acute angles to be an acute triangle. It only takes one obtuse angle to make it an obtuse triangle. That's because every single triangle has 2 acute angles. Every triangle has 2 acute angles. So everything is based on the third angle. Okay, you're going to have 2 acute angles. So that third angle has to be acute. All 3 have to be acute for the triangle to be acute. For an obtuse triangle, you're going to have 2 acute angles, 1 obtuse angle. So one possible example for an obtuse triangle could be this. Okay, the 20 degrees and 30 degrees, both of those are acute, but it's got one angle bigger than 90. It's got one obtuse angle. That makes it an obtuse triangle. Okay, a right triangle is a triangle that has one angle with a measure of 90 degrees. So it has one right angle. Because again, it's going to have 2 acute angles. So everything's based on that third angle. So if that one angle by itself is a right angle, 90 degrees, then this is going to be a right triangle no matter what the other 2 angles are. And equiangular is a triangle with all 3 angles that are congruent. All 3 angles are congruent. Now, something real quick I'm going to bring up that's at the bottom of this page is the triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180 degrees. In every single triangle, the 3 angles inside that triangle have to add up to 180 every single time. And you'll notice I kept that constant throughout all these examples. In each one of these examples, if you add the 3 angles up, it should add up to 180. In an equiangular triangle, if these 3 angles are going to all be congruent and they're all going to add up to 180, 60 is the only thing they can be. You just take 180, divide by 3, you get 60. Okay? These angles have to be 60 degrees for this triangle to be equiangular. So while an acute triangle might have three different numbers, equiangular triangle, they all got to be 60. I could come up with another acute triangle and change these numbers. As long as they're all less than 90 and they all add up to 180, it's still an acute triangle. But equiangular, this is the only possible. I can't come up with any other number. I can't say 50, 50, and 50 because those aren't going to add up to 180. They won't make a triangle. And I can't make them different numbers to add up to 180 because then it wouldn't be equiangular anymore. So every equiangular triangle has three 60-degree angles. Now you might also notice that those are all acute angles. So technically an equiangular triangle is an acute triangle. But anytime we classify triangles, we want to be as specific as possible. So anytime you have an equiangular triangle, don't call it acute. Go ahead and call it an equiangular triangle. All right, so let's look at example 3 here. Classify the triangles by angles. So notice all three angles are 60 degrees, so this is equiangular. Here, that's an acute angle, less than 90, acute, acute. All three angles are acute. That makes this an acute triangle. 35 degrees is acute, 30 degrees is acute, but 115, that's obtuse. It only takes one obtuse angle to make it an obtuse triangle. So that's an obtuse triangle. And over here, I don't necessarily know exactly what these angles are, but it only takes one right angle to make this a right triangle. So I know this is a right triangle. All right, turning the page. All right, find the measure of the third angle of a triangle if the first angle has a measure of 66 degrees and the second angle has a measure of 37 degrees. Remember, we just learned a moment ago that the three angles in a triangle always add up to 180 degrees. So if I want to set this up as an equation, I got one angle I don't know, I got a 66 degree angle, and I got a 37 degree angle. And those three should all add up to 180 degrees. So we're just setting up the equation. So then we can combine like terms, 66 and 37. And what is that? 103. Oops, that should be a plus sign right there. Still trying to solve for x. We need to subtract the 103. And there it is. X is 77 degrees. The angle that's missing is 77 degrees. Now, if you don't want to be formal and set up the equation, anytime you have a problem like this, you're just adding the two angles that you have, adding those together, and then subtracting it from 180. So either way, the reason it's important to be able to set up an equation like this is if they give you the same type of scenario but with more variables. If they gave me an expression for this angle, an expression for that angle instead of just a number, then we would need to know how to set up the equation and do it this way. So if you get a problem exactly like this, you can do it the short way right over here, that's fine. But make sure you know how to set up the equation and do it this way as well. For example, find the measure of each angle of triangle RST. And notice this time they gave us expressions for all the angles. So not going to be able to do this shortcut over here. So we need to know that these three angles add up to 180. And we need to set it up that way. X plus 3x plus x plus 40 equals 180. When I add all three angles together, it should add up to 180. So now we're just solving an equation. Let's see, 1 plus 3 is 4, plus one more, you got 5 x's. Trying to get x by itself, I got to get rid of the 40. And then we got to get rid of the 5, so we're going to divide by 5. Alright, you get x is 28. Now our goal is to find the measure of each angle. So now that I know what x is, I need to substitute it back in for each one of these. So if I want to find the measure of angle R, that was 3x. Well, since I know x is 28 now, I substitute 28 in place of x. 3 times 28 is 84. So the measure of angle R, 84 degrees. And when I find the measure of angle S, this one's easy, it's just x. So I substitute 28 in for x is 28. And then we have the measure of angle T is x plus 40. Substitute the 28 in for x. 28 plus 40, 68. So the measure of angle T, 68 degrees. All right, let's find the value of x on 6. And this is kind of helping you out with the whole equiangular thing. Notice each angle is the same, right? So if I were to add those together, x plus x plus x equals 180. If I combine like terms, I got 3 x's. Then I divide off the 3. And there you go. Each angle has to be 60 degrees. Because it's equiangular. We talked about that earlier. Anytime you got an equiangular triangle, it's going to be 60 degrees. Okay, so this is an equiangular triangle. Based on this example, we can say that each angle of an equiangular triangle is 60 degrees. And something else you might want to know is if a triangle is equilateral, then it is equiangular. If a triangle is equiangular, then it is equilateral. Remember earlier I said in that isosceles triangle theorem, because two sides of the triangle are congruent, it had two congruent angles. Same kind of concept with the equilateral triangle, except this time we have 3 congruent sides, so we end up with 3 congruent angles. In a triangle, however many sides you have congruent, you're going to have the same number of angles congruent. However many angles you have congruent, you're going to have the same number of sides congruent. So in a scalene triangle, all the angles are going to be different because all the sides are different. In an isosceles triangle, you have 2 sides congruent, so you're going to have 2 angles congruent. In an equilateral triangle, you're going to have all 3 angles congruent because all 3 sides are congruent. All right. Let's do example 7. Find the value of x. So again, remember the 3 angles in a triangle always add up to 180 degrees. So I got 3x plus 2 plus 2x plus 3 plus 90 equals 180. Remember, a right angle is always 90 degrees. So there's the equation. I'm going to combine like terms. 2, 3 is 5. 5 plus 90 is 95. Subtract the 95. And divide off this 5. And we ran out of room right there. Should get x is 17. Alright. Now, angle J and angle L are acute angles. Remember, every triangle has 2 acute angles. So if this is a right angle, it's not acute, so the other 2 have to be acute. Their sum is 90 degrees. The reason we know that their sum is 90 degrees is all 3 angles add up to 180. So if this is 90 degrees, what's left? There's 90 more degrees left. So these 2 angles have to add up to 90 degrees. So we can say that acute angles of a right triangle are complementary. So just know that in every right triangle, the 2 acute angles add up to 90 degrees. The 2 acute angles are complementary. Alright, should be shifting to a new topic here. An exterior angle of a triangle is formed by one side of a triangle and the extension of an adjacent side. So for example, down here, here's a triangle. If you extend one side, this extension and this adjacent side, those create that exterior angle right there. So angle 1 is an exterior angle. Alright? Exterior angles theorem. The measure of an exterior angle of a triangle is equal to the sum of the 2 remote interior angles. Alright, that word remote, think of a remote control. What makes it a remote control is that you can control the TV or the stereo or the VCR or whatever it is. VCR, that's old. The DVD player, Blu-ray player. You can control it from a distance. Back in the day, we used to have to change the channel and the volume on the TV. You couldn't do that from the couch. Now we have a remote control. We are now able to control the television from a distance. We don't have to stand right at the television to make those changes. Okay. I mentioned just a moment ago that angle 1 is an exterior angle. There are 3 interior angles in this triangle. One of those interior angles is adjacent to the exterior angle. Angle 2 is adjacent to angle 1. So there's nothing remote about this. This is like the person standing right next to the television. They're side by side, right in front of each other. So these 2 interior angles are the remote interior angles. They're the interior angles that have a distance from that exterior angle. Okay? So an exterior angle is equal to the sum of the 2 remote interior angles. So what that tells me is that angle 1 is equal to the sum of these 2 angles. 80 plus 40. So 80 plus 40 is 120 degrees. So the measure of angle 1, 120 degrees. It's equal to the sum of the 2 remote interior angles. So let's look at example 9 then with that information. In triangle XYZ, the measure of angle X is 63 degrees. And the measure of angle XYZ is 53 degrees. Find the measure of angle ZYR. We want to find the measure of this angle right here. Alright, you got a couple different ways you can go about doing this. Let's do it first using the exterior angle theorem here. The 3 angles in a triangle should always add up to 180 degrees. So I can find this angle up here, angle Z, by adding these 2 angles together and then subtracting that from 180. So I know that this angle right here is 64 degrees. Now remember, an exterior angle, like angle ZYR, is equal to the sum of the 2 remote interior angles. Again, this angle is adjacent to the exterior angle, so it's not remote. I want the sum of these 2 angles. So if I add those 2 angles together, I'll know what that exterior angle is. That exterior angle is 127 degrees. Now, we could have done this problem without that new information that we just learned today, though. But just to show you that it works the same, these 2 angles are a linear pair. Hopefully you recognize that because we've dealt with linear pairs multiple times. And the 2 angles in a linear pair are always supplementary. They always add up to 180. So, if this angle is 53 degrees, I can subtract that from 180 and find out that this angle is 127 degrees. So there's 2 different ways to do that one. And in this case, knowing what a linear pair is actually quicker and easier on this problem. But just to show you that it did work the other way as well, just to prove that that exterior angle is equal to the sum of the 2 remote interior angles, we went ahead and did it both ways. There will be times that you need to use this because you won't be able to use the other. So let's look at example 10. In triangle EFG, the measure of angle G is 100 degrees. And the measure of angle FEH is 3 times the measure of angle F. We want to find the measure of angle F. Since we don't know what the measure of angle F is right now, but we apparently want to find it, I'm going to put an X there. That's the variable that represents what we're wanting to solve. And while they didn't tell me exactly what the measure of angle FEH is yet, they told me it was 3 times the measure of angle F. So if the measure of angle F is X, 3 times X would be 3X. So I'm going to label that exterior angle with 3X. So hopefully once you've taken that information and put it into the picture, you can see how we're going to set this problem up. Remember that the exterior angle is equal to the sum of the 2 remote interior angles. So the exterior angle is equal to the sum of the 2 remote interior angles. It gives us this equation right here. And now we're solving for X. I don't want X on both sides, so I'm going to subtract to get rid of it. And then I got to divide off the 2 to get X all by itself. And our goal is to find the measure of angle F. Since X is 50 and X was representing the measure of angle F, we substitute that in there. The measure of angle F is 50 degrees. And you can double check yourself if you need to. 3 times 50 would be 150. And 100 plus 50 would be 150. And that's the end of those notes.